right, so here's all the information that you're going to need to go back to and read a couple times. Oops. Oh, all right, so the F1 and the F2, those are those points we were just looking at, and those are okay, I think you can also say foci. I think people say it different. There are two equations for ellipses. You look very carefully. They're really similar. You see a difference between these two equations? What's the difference? One of them has a squared under x, and the other one has a squared under y. That's the only difference. You will know which one is a squared because it's the bigger number. So that's how you will know which equation we're using. The two circles that were used, the radii were used to form this ellipse. We're never going to draw the circles, but you are going to find the foci. But I just wanted to explain what they were. I don't want you to find something and be like, I don't know what it is, but I have to find it. But that's why we were finding it, because it is related to a circle. All right, the center of the ellipse is HK, and it's the same like it was for circles. You see the H and the K exactly the same as it was for circles. But what's different about these equations than circles is these equations always equal 1. The circles always equal the radius, but these always equal 1 to be in the standard graphing form. So we need to make sure that it equals 1 before we find any information. To graph ellipses, you're going to have a major axis and a minor axis. So in ellipse, you guys know what an ellipse kind of looks like. I'm going to draw two of them. Here's one. Here's the second one. Now, within this ellipse, we have a major axis and we have a minor axis. Can you guess why I'm calling the blue one the major axis? It's longer, right? Here's the major axis in this one, and here's the minor axis. And right in the middle where the two axes cross, that's the center. So you're going to be finding the center, and you'll be finding all these points on the ends, on the endpoints of the axes, and those are called vertices. Those are all kinds of words that you've used in previous courses. Those are vertices. It's also up here too. Vertices. How you know which one goes horizontally and which one goes vertically, it depends where a squared is located, where the bigger number is. If the bigger number is underneath the x squared, then it's horizontally longer. If the bigger number is under y squared, y squared, then it's the vertically longer one. The length of the major axis is 2a because each little half of it is a units long. And where am I getting a from? Where am I getting a from? From that number, but the square root of it. So in this equation, this is a long, and this is a long. So the whole axis itself is 2a. Each little individual half is a. And then likewise, the minor axis, each little piece is b long. And we're getting that number from b squared. So each little piece here is b long. So that's how you're going to find all that information. You're going to plot it. You're going to graph an ellipse. Then you also have to find the foci, and to do that, there is an equation. The equation is given right here. You do a squared minus b squared equals c squared. The distance from the center to the foci is c. So you do b squared, or a squared minus b squared equals c squared, but then you have to find c. C gives you the foci distance from the center. And it is always on the major axis. Always on the major axis. So somewhere on this longer axis, there are going to be these foci points. Somewhere. And where it is depends on the equation. But somewhere on the axis gives you this foci. That's all vocabulary. So what we're going to do is we're going to go through all of these examples. We'll take a quick little break halfway through. We go through all these examples. And that is just to give you stuff to go off of when you do your assignment. All right? And hopefully, I don't expect these to make all of this stuff to make sense the very first time you see it. You have to practice and practice it, then it really makes sense to you. There we go. So the very first one, graph the following and state all necessary information. So 8 is x squared plus 9y squared equals 9. Is this in the correct format, the standard graphing form of an ellipse?
No, it has to equal 1.
Has to equal 1. And you can see this does not equal 1. Divide by 9 to make it equal 1. Yeah. So we'll have x squared over 9 plus y squared equals 1. Under the y squared, we will need that value, so I'm going to write it. Usually I would not, because the 9 and the 9 would cancel out. But since I need that value, what is under that y squared? That's a 1, right? So then we got to determine, first of all, where's our center? 0, 0. Good. Because there's no h or k. Let's go ahead and plot that. And we got to figure out major axis and minor axis. So we need to look for the bigger number. Where's the bigger number? 9 or 1? 9. So this is the a squared. Because it is under x, it's going to be a horizontal kind. We'll just put, make a little note so you have notes to go off of later. I'm just like writing down as much as I can. I would encourage you to write more than less right now. All right. So my a value is not 9. My a value is 3. That means from the center, we go out 3 in which direction? Left and right. So what ordered pairs are the major vertices? Now there is a way to get that without graphing it, and I'm going to do it the other way the rest of the time. You can see how to do it without graphing it. But I want you to understand that these points are there because we're going from the center, we're going out 3. Minor vertices. So we need to know what B is. B is 1. Well, B squared is 1, so B is also 1. So the minor vertice, that one's going to be vertical. That means we're going to go up 1 and down 1 from the center. What ordered pairs are those? And at that point, you can carefully draw an ellipse. Try not to make it look like a parallelogram or rhombus. Some people make it look like. Try to round it. Take some practice. All right, and then we have to find our foci, and we're going to graph our foci also. So the equation is c squared is a squared minus b squared. So how do I know which one's a squared? Bigger one. So I do 9 minus 1. So c squared is 8. That means c is what? Yeah. Make sure you are simplifying radicals. So the ordered pairs for these foci, I mean, we go on the major axis. So is that going to be horizontal or vertical? It is also horizontal, whatever the major is. And we're going to go from the center, and we're going to go out to radical 2 in both directions. So we'll have negative 2 radical 2, 0, and then positive 2 radical 2, 0. How do I plot that? I need to make it a decimal to plot it. That's the only time I'm going to make it a decimal so I can graph it. So in your calculator, somebody's got one out. What's 2 radical 2? 2.8-ish. So from the center, we're going to go out 2.8. And you probably have an easier time trying to do it on there because mine's hard to draw really tiny. But still, it is kind of hard to draw on this. Yeah.
So you can use horizontal because the
Bigger ones under F. Yep. When you do your homework, the way we are modeling it in class is what I expect to see. If you look in the back of the book and see that they did it differently, I don't want you to do what the back of the book does. I want you to do the way we do it in class. Okay? All right, next one. First thing is it in the correct form?
Yes. Yes,
All right, if it is, we have to find the center. Positive 1, negative 3. Exact same way we found the center for the circle. Major vertices. It is going to be vertical, yes. Be vertical because 36 is the bigger number. That's a squared. So a is 6. That means that we are going to go from our center up 6 and down 6. So I'm going to show you how to do that without graphing it. And then we'll graph. I mean, it's easy to do a graphing. I just count up 6 and down 6. But to do it using points, I'm only going up and down so I don't change the x. I keep my same x. But my y's, I'm going to take that negative 3 and I'm going to add 6 or I'm going to subtract 6. And I'm not going to leave it like that either. I'm just going to write. You might be doing this part in your head. I'm writing it down because it's notes. You won't write it like that on your paper. You'll write it like this. 1 comma negative 9 and 1 comma 3. You would actually add or subtract the 6. Okay? So then 1 comma negative 9, 1 comma 3. So my minor has got to be horizontal. My b squared is 25, so my b is 5. So when I go to do that by hand, I'm taking the original center point and I'm changing the horizontal numbers. 1 plus or minus 5, comma, negative 3. So I'll have 6, negative 3, or negative 4, negative 3. This warm air is putting you to sleep. Open this up, but gotta do something to stay awake because this is not the lesson to sleep through. So yeah, we're gonna find our foci, and we're gonna do a squared minus b squared. What's that? So when I subtract these, you're subtracting the bigger number, like bigger number minus smaller number. A squared is always a bigger number. 36 minus 25. So C is square root 11. So when I write my foci, it goes horizontally. So we use the original center and we change, just kidding, it's vertically, I don't know what I'm talking about. Just make sure you're awake, that's all. Okay, so it's vertical. And we're going to use the horizontal 1 because that doesn't change. For the vertical, -3, we're going to add square root 11. And then 1 comma -3 minus square root 11. And those ordered pairs, we're going to leave in radical form because that is the most exact answer. But to plot it, I need to actually find a decimal. Who's got square root 11? So from the center, we're going to go up 3.3 and down 3.3. All right. Not terrible stuff. It's just takes a little bit of time and concentration. I'm going to write down a lot of information. Try to really round it. It shouldn't look like a diamond. All right. Ready for the next one? I hear some enthusiasm. Is that one in our nice standard graphing form? So what are we going to have to do? What's that called?
I don't know. Especially C.
Uh-huh. Okay. Save some space. I'm going to reorder it. And I'm going to move my 84 over. Start by reordering it and move my 84 over. Maybe you could combine a few steps and do the second step at the same time as the first step. I'm going to factor out 16 from x squared and the x. I'm going to leave a space. Out of the y, though, I'm only going to factor out 4. Okay, so I'm factoring out different numbers from x and y, and that didn't happen on last night's homework because they were circles, but it will happen on this homework because they're like ellipses where they're stretched one way, so it's going to be different amounts that you factor out. So what goes in this first complete the square? 9. So what do we add over here? 9? Ooh, you add 16 times 9. 144. All right, and then what do we put in this spot? But what do I add to the other side? 4. So then I'm going to factor. I'm going to get 16 multiplied by x plus 30 squared plus 4 multiplied by y minus 1 squared equals, and I add all that up and times what it is. Yes, what do you
How
mean?
did you get one? Oh, wait.
Did you answer your own question?
Yeah, I just put it on the.
What is it? 64? Is that what it is? Okay, so is this the standard graphing form? Has to equal 1, so what am I going to divide everything by?
64.
So when I divide this side by 64, I will get 1, but what happens when I divide over here? It becomes a 4 on the bottom, right? So we'll have x plus 3 squared over 4 plus y minus 1 squared over 16 equals 1. I write our equation. So is this going to be horizontal or vertical? It's going to be a vertical one, right? All right, where's our center? -3, 1. So our A value is 4. So we're going to take the center and we're going to change the vertical number, 1 plus or minus 4. But that's not how you write your answers. We're going to actually do the addition or subtraction. So I'm going to have -3, 5 and -3, -3. That's going to be my major vertices. Questions? So the minor vertices, I need my B value, and my B is, there's B squared, so B is 2. And since it is horizontal for the minor, we're going to take the X values and change those. I'll have -3 plus or minus 2, comma, my Y value 1. But I'm not going to leave it like that. I'll have -5, 1 and -1, 1. All right, then we need to find our foci. So we do c squared is a squared minus b squared. So c squared is 16 minus 4. C squared is 12, so c is 2 radical 3. And the foci, are those going to be horizontal or vertical? This is going to be vertical also. So we're going to use our center point, and we're only going to change the vertical variable, the 1. So we'll do 1 plus 2 radical 3, and then -3, 1 minus 2 radical 3. To graph it, we need the approximate decimal, 3.46, 3.5. And that's how high up and down 1. There. So, quick little question. What happens if you complete the square wrong? Well, yeah, you won't get any of it right. Yeah. It's all going to be wrong. Because everything goes off of you doing that first step right. So it's very important that you take your time and understand how to do the complete square. Let's work through that last one before we take a brain break. So I'm going to stop talking for a moment and give you a chance to start working through it on your own. But don't do it all until you've made sure your equation is completed right. Good. Alright, so I have my equation, x plus 2, or x minus 2 squared over 1 plus y minus 1 squared over 25 equals 1. So our center is at 2, 1. The major vertices, we're going to take 2 and we're going to have 1 plus or minus 5, which is going to give us 2, negative 4, and 2, 6. Minor vertices, you're going to change the x's, 2 plus or minus 1, comma 1. So we'll have 3, 1, and 1, 1. Then for the foci, we have to do c squared is a squared minus b squared. So we're going to have 25 minus 1. So when you square root that, you get 2 radical 6. When you go to put that in the foci, it is vertical, so we're changing the y value. You're going to have 2 comma 1 plus 2 radical 6, and 2 comma 1 minus 2 radical 6 for your ordered pairs. To graph it, I'm just going to approximate 2 radical 6 as 4.9. Question? Do you want me to scroll up? Is there